Okay, everybody. Oh, I am not in my living room this time. I'm actually sitting in my chair at my desk in our classroom. So how do you like that? Well, we should probably look at this little, I don't know what you want to call this. I guess it's like a worksheet, but it isn't. It's a picture. It's a JPEG. Anyway, we have some questions to answer here. Like, for instance, what is the velocity of this object? Okay, let me remind you. We're dealing with a position. Oh boy, this thing's not cooperating. A position time graph. Okay, what do we know about the slope of a position time graph? You're supposed to know what this is. Let me write a couple things here. Slope of a position time graph, remember, would be like this thing that we used to do in class all the time, right? And you'd find your rise or your delta x over your run, your delta t, and that is your slope, your delta x over your delta t. And what do we call that? That has a name. Oh boy, my t is all messed up. Gosh. Okay, hold on. Let me undo. There. Okay. So, what do we call that? Okay. Slope. Oh my gosh, my equal sign is messed up too. So, slope is delta x over delta t, which for this graph we call something. It has a name. Oh, yes, that's right. That is velocity. Velocity. The slope of the graph is the velocity. That's question one. So when I said yesterday that most of this stuff was right in front of your face, it is. 4. So, answer to question one, the velocity is 4. For what? For meters for every second. Meters per or for every second. Now, starting position. Let's see. Oh boy. We've been talking about this little place here where your line crosses the y-axis, where the best fit line crosses the y-axis. It has a name. It's called the y-intercept, which is, for this kind of graph, the position, which is on this axis, the position when time is 0. Time is 0 here. Okay, time is 0 right there. Right there. Position is 0 right here. Is this 0 position? No, it is not 0 position. Well, what position is that? Right there. The y-intercept value, which I gave you, is 12. 12 what? 12 meters. So, starting position is 12 meters. Is that a positive or negative starting position? Positive, because it's above the 0. If it were below the 0 down here, then it would be a negative, but it's a positive because it's above. So, 12 meters. Motion map. Okay, what does the motion map look like? Well, something else I guess I should probably talk about. When I said 4, is that a positive or negative velocity? That's a positive slope. Therefore, we have positive velocity. I didn't put a plus on it. Maybe I should have. I don't know. That's a positive 4 meters per second. Starting position is positive, oh boy, that doesn't look like it. It's a positive 12 meters. Motion map. Back to the motion map. Okay, first of all, mark out your 0 position. What direction is positive? Now, your first dot, remember, the first dot is the starting position of positive 12 meters. Well, where's positive 12? I don't know, somewhere out here. Well, how do you know how far out to make it? I don't. I'm just making it up. Now, that's for the first dot. How about arrows that are going to be on here? Well, we know the velocity is positive 4 meters per second. Therefore, our arrows better be in the positive direction, and they better all be what? The same length. Now, how long was that happening? I don't know. Is 4 dots and 4 arrows enough? Sure. Is that communicating to us what's really happening? Yes, I think. In fact, I guess we could jump ahead and answer number 5 first before we answer the next one. So number 5 says describe the motion in words. Well, if you look at the motion map here and you look at the graph, what is this telling us? It's saying to us that the object starts not at the 0 position, but the object starts with a positive position of what? 12 meters. Traveling in the positive direction with a constant velocity of 4 meters per second. You could say positive 4, but we already said positive direction, so we kind of took care of the direction already with the plus saying positive. So how do you actually, what should that look like written out? Okay, I would say object starts with, that was my phone, oh no, that was my phone, did you hear that? It rang. Object starts with a plus 12 meter position. Travels, boy this is hard to write with this thing, in a positive direction with a constant, oh boy, oh my gosh, I can't even, that's terrible. I don't even know, is this, oh boy, with a constant velocity of positive 4 meters per second. There we go. There's your statement. Okay, so that's number 5. Check that off, check that off, check this off, check that off. We have 1 left. So where is the object after 5 seconds? Well, this is not going to be found looking at our graph. Now, if we happen to have some values here and some numbers, then you could just look at 5 seconds down here, head on up. You can look at 5 seconds, wherever 5 seconds is, go on up to the line, hang a left, go on over to the position axis, and that would be your answer. But we don't have that. We do not have any values here, so you can't read the graph. So the only way you can figure this out is to use the equation. What equation? I don't see an equation. You have to write the equation for the line. Remember, y equals mx plus b. This is the same equation you wrote for the tumble buggy for your lab. It's the same equations we've been writing with all of the different graphs we've been looking at. So, y, our y variable is what? Position. So, write out position. Oh boy. You could write just x if you want, if you remember what x is. This is terrible. So, position equals, well, what's the slope? The m is the slope, of course, and the slope we found out was 4. So, for what? Meters for every second. Parenthesis that. What does the x represent? The x represents the variable on the x-axis, which is time. So, write out time. Time for my x variable plus, you can't forget about the b. You gotta remember there's still a b out there. And what's the b? The y-intercept, which is what? 12. 12 what? 12 meters. You better be putting, oh boy, we got intercom time. Here's the announcement.
Please report to the office. Missy Smith to the office.
Did you get that? 12 meters. So this is my equation, all right? Position equals 4 meters per second, which is the velocity, times time, plus the 12 meter starting position. That's my y equals mx plus b. Now, that's not the answer. The answer is, where is the object after 5 seconds? Well, notice, if I have an equation, what do I put in for time now? Maybe 5 seconds? Sure. So, position, I'll abbreviate now because I'm running out of the ability to write, 4 meters per second times 5, oh my gosh, this is terrible, 5 seconds, sheesh, plus, you can't forget the plus 12 meters, people, plus 12 meters. So notice what's happening. I have to take 4 meters per second times 5 seconds. What happens to my seconds? Seconds cancels seconds. And I end up with what? 4 meters, that is, times 5. Oh, and what's that? That is 20 meters. Plus, don't forget about the y-intercept. I still have 12 meters out here. And that's a total of what? 32 meters. So where is this person? After 5 seconds, the person is at 32 meters of position. Now, how far did the person travel in those 5 seconds? That's the 20. The 5 seconds, there was 20 meters of travel in the 5 seconds, plus the additional 12 meters because the person started at 12 plus the 20 they traveled is the 32 total meters of position at the end of the 5 seconds. I hope that makes sense. I hope you've enjoyed this wonderful whiteboard video that I made in the comfort of my own desk chair in my own classroom. I hope you have a great rest of the day. Good luck on the quiz. And I will most likely see you tomorrow, if you're lucky.